Welcome guys. In this video we are just going to look at the formation of nylon under the organic chemistry. So nylon can be seen as a polymer. So according to chemistry, how do we define a polymer? So polymer is a large molecule made from the combination of two or more smaller subunits known as the monomers. Right. So if a nylon is a polymer, we also have to look at the process by which these polymers are made. So they are made by polymerization. Now we have two types of polymerization. The first one is what we call addition polymerization. So the addition polymerization deals with the adding of alkanes. So here we have alkanes. Then the second one is where we look at condensation polymerization. Now the difference between the two is that under condensation polymerization, water is also formed. Then for addition polymerization, no water molecule must be formed. Now, between the two types of polymerization, which one is associated with the formation of nylon? So nylon is an example of condensation polymer. So that is what you need to know. Then now, the same condensation polymerization can be divided into two. We are going to look at the first one, what we call the synthetic polymers. For example, nylon is a synthetic polymer. Why is it called a synthetic polymer? Because it is a man-made. So these are made by human beings. Then the second one are what we call the natural polymers. So the natural polymers are polymers like fats, proteins, carbohydrates. All these are examples of natural. Why? Because they are not made by human beings. So let's hope we've cleared what it means by synthetic and natural polymer. Now, away from there, we also have to look at what is the general formula, or let's say equation, that can represent condensation polymerization. So let's say we have a monomer plus another monomer. Let's just say we have two monomers. We combine them, they will give us a polymer. In our case, let's say a nylon. Plus what else are we supposed to have? It's water. So if this was addition, the addition will just end at the polymer. So as long as polymer is produced, minus giving us the elimination of water, then such type of polymerization is what we call the addition. Now, since our focus is on nylon, we need to look at what are the monomers for nylon. So the first one is diamine. The second one is dicarboxylic acid. So what is the polymer for these two monomers? Is nylon, remember, plus water. So now for this one, we can now focus on the structure. So the structure is where now our focus is. So under the structure, you may have come across these boxes. It may be maybe in books or videos or in papers. So we want to look at what is really meant by these boxes. So for a diamine, we have a functional group known as the amine. So the amine represents the functional group present in the monomer called a diamine. So it is denoted by nitrogen bonded to 2 atoms of hydrogen. So whenever you see this, just remember that this is a functional group for an amine. So we are going to have another functional group. So why do we have 1, 2? So why do we have 2 functional groups? Because the name indicates diamine. Remember, di simply means 2. So we move on to carboxylic acid. So I'm going to do the same. I'm going to draw a box. Now, this box, I'm going to shade it. Or in some papers, you may find the one box shaded and the other one unshaded. So what's the difference? So the difference is that each box represents a number of carbon atoms. So if one is shaded and the other one is not shaded, it simply means the 2 boxes have different number of carbons. But in most cases, each box represents 6 atoms of carbon. So here, I'm going to write the functional group for acids. So this is the functional groups for acids. So as we can see, we have 1, 2, that's the name dicarboxylic acid. Now, when coming up with structure, we are going to now remove hydrogen from the amine. So this bond will break. Then from the carboxylic acid, we are going to remove hydroxide, so that the hydrogen from the amine and the hydroxide from the dicarboxylic acid will now give us the water that is produced. Therefore, we're now connecting what remains. You do this. So I'm writing the first box. We have this bond here. We have this nitrogen here, this hydrogen and the other hydrogen. Then we have this nitrogen, this hydrogen. Now this remaining bond will connect with the other remaining half, giving us a complete bond. Then we have this carbon atom here, then the shaded box, then we put the other point plus H2O. Right, so we've seen we have water. Therefore, this is a condensation polymerization. Now, we can have a long chain. For example, we can have this box here, like this. Like this, so it can be as long as you can write, depending on the number of the monomers that you have used. Now, no matter how long this polymer is, I want you guys to look at what we have. So what we have in between the 2 boxes is called the linkage. Why is it called the linkage? Because it is connecting the 2 boxes. So it is connecting this box from the dicarboxylic acid and this one from the diamine. So that's why it is called the linkage. Now, what special name is given to this linkage? So this linkage is called amide linkage. So this is an amide linkage, or sometimes you may find this one as a peptide linkage. Sometimes they may call it a peptide bond. And this linkage is the same linkage that you are expected to find in proteins. The only difference is the proteins are natural while the nylon is a man-made substance. So this is what you have to know about the nylon. So that's it for this video. Thanks for watching.